This is 2.6, part 3, absolute value equations. So let's take a look. What if you're given the absolute value of x equals k, and k is some constant? Well, this will generate two solutions. You will have x is equal to k, and you'll have x is equal to the opposite of k. Think about that. If I put a negative number in here, I can come up with the same value as if I put the positive of that same number in the absolute values. So it makes sense. What do our solutions look like? They are actually two different values. Your solution set will be the opposite of k and k. You only have those two. Now we do have some special cases. I'll have you pause the video and write a few problems down at the end. I'm just giving you a heads up. I do want to mention, if you ever have an equation similar to B, where you have the absolute values on both sides, that's what this comment is about here. It is the same thing. You just have A equals B or A equals the opposite of B. It's just the same as above. So don't let that bother you. Okay. Let's give this a try. The absolute value of 9 minus 4x is equal to 7. We just said that that would be 9 minus 4x equal to 7, and also 9 minus 4x equal to the opposite of 7. So we will have an equation with 7 and negative 7 in it. That's when we can take these absolute values off. We are allowed to take these absolute values off when we let that equation equal 7 and also negative 7. Okay? And now we just solve both of those. Let's subtract 9 from both sides and divide both sides by a negative 4. And we get x equal to 1/2. Let's subtract 9 from both sides. And let's divide both sides by a negative 4. And we get x equal to 4. I'm going to go ahead and write our solutions in this section in a solution set. You can do that, or you could just circle both of your solutions. But I want to point out that we end up with two solutions. Okay? Here's our case with absolute values on both sides. In order to take the absolute values off, we will solve 3x plus 2 equal to x minus 5. Now be careful here. 3x plus 2 equal to the opposite of x minus 5. The opposite of all of x minus 5. Okay? We'll have to distribute that negative. Let's solve this one first. I'm going to, subtract x from both sides. 2x plus 2 equals a negative 5. Now I'll subtract 2 from both sides and divide both sides by a positive 2. Let's take a look at this over here. Let's first distribute that negative. So we have the opposite of x plus 5. I think I'll add x to both sides. Now I'll subtract 2 and divide both sides by 4. So our two solutions are negative 7 over 2 and 3/4. And order doesn't matter in that set notation. It's good for you to see that. Let's keep going. How about the absolute value of 5 minus 3x equal to 12? Let's take a look there. In order to drop those absolute values, we have 5 minus 3x is equal to 12, and 5 minus 3x is equal to negative 12. I'm going to subtract 5 from both sides, and then I'm going to divide both sides by a negative 3. Let's subtract 5 and divide both sides by a negative 3. And we have a negative 7/3 and a 17/3. Okay? Take a look at this over here. Two absolute value signs, not a problem. We're going to solve 4x minus 3 equals x plus 6, and 4x minus 3 equals the opposite of x plus 6. Okay? Go ahead and solve both of those. You can pause the video, and then you can check with my work. Okay, if you're just turning the video back on, you can see the work, and you should have 3 and a negative 3/5 for your solutions. Okay, let's look at E. We have to isolate that absolute value before we can use this property. Do you see how this is isolated all by itself on that one side of the equation? Okay, so we need to isolate that. So we will add 3 to both sides. Now we can drop the absolute value signs and say 2 minus x is equal to 3, and 2 minus x is equal to the opposite of 3. I'm going to subtract 2 from both sides, and then I'm going to multiply both sides by a negative 1. I'm going to subtract 2 from both sides, and then multiply both sides by a negative 1. We end up with a negative 1 and a 5 for our solution set. Okay, let's talk about a couple special cases. And I wanted to bring that up because I think if you ever come across these, you might be happy we went over this, okay? And you are expected to know this. What if you're given, let's say, the absolute value of 7x plus 28 is equal to 0? Pause the video a moment if you need to write that down. So following the same rules, it must be that 7x plus 28 is equal to 0, or 7x plus 28 is equal to the opposite of 0. Well, there is no opposite of 0. I guess there is. The opposite of 0 is 0. So in this special case, we are only solving one equation, although we were solving an absolute value equation. Okay? So that's a really good example. So here we only have to solve one equation. I have another special case I would like to show you, and it looks like this. I can call that special case number 1, and I'm going to give you special case number 2. What if you were given, let's say, 2x minus 7 is absolute value of 2x minus 7 is equal to negative 3? Now think about this. If you take the absolute value of anything, will it ever equal a negative? Never. It's always positive. So this is the null set. There are no solutions. So it's a really good example. So if you take the absolute value, you isolate the absolute value, and you end up with a negative over here, on the right-hand side, there is no solution. And that ends this last part of section 2.6.